of other stuff, such as how much time they get to spend relaxing, how secure they feel about their identity, how enjoyable their work is, and other things. And utility is assumed to be concave in income. This is the basic idea of risk aversion, which I think you guys learned last term. And I think the basic intuition behind it is that, as you get more money, you sort of run out of good uses for it. The first thing you buy when you have some money is like some food, then you buy a place to live, then you buy, clothes, and the more money you get, the less things you have to spend it on that are really productive. It's important to note that not everything bad that happens to you necessarily calls for insurance. So there can be things that happen to you that are really bad, but that don't increase the marginal utility of wealth. So for example, if you're disabled, it's not clear that money is worth more to you than when you're well functioning, right? Because you may not be able to do very much to enjoy your money when you're disabled. Or if you have a girlfriend who's really high maintenance, right, and she leaves you, that might actually be a real bummer, but it might also decrease the marginal utility of wealth, right, because you were using all your money to spend on her, right? We'll return to this point a little bit later in the lecture. But now let's just focus on the idea of how risk aversion, or the concave marginal utility of wealth, gives an incentive for redistribution. And to do that, it's useful to have a more specific form for the utility function, rather than just to say that it's concave. Because this will help us determine exactly how much redistribution is going to be optimal. And the nice thing is that there's actually really strong evidence, the same way there was with Zipf's law, about what people's utility functions look like as a function of their wealth. And basically, the form that we have the best evidence for is this, that the utility of income is equal to the logarithm of your income, the natural logarithm. And this is actually very intuitive. It's sort of the first thing you would think of. It basically says that the value of increasing your wealth, doubling your wealth, say, is the same regardless of what wealth level you start at. So if you move from making $10,000 a year to making $20,000 a year, that's about as good as moving from making $1 million to $2 million a year. Mathematically, it's very convenient, and most importantly, it has a lot of empirical support. So there's a number of different studies that have given support to this, but let me show you one that I think is particularly striking. So Dan Sachs and co-authors studied subjective well-being data. This is where you ask people on a ladder of life where 0 is the worst life you can imagine yourself leading and 10 is the best life you can imagine yourself leading, where would you place yourself? And let's call people's response to that question H, and let's call their income, to be technical, real income at purchasing power parity, because we're going to compare across countries, I. And what he finds is that the specification H, your subjective well-being, equals 0.35 log I plus some noise, fits incredibly well. And I'll show you a graph of this. It's actually astonishing. So what he's done here is, here's a whole bunch of countries in the world. And within each country, you can run this regression across different people who are in different incomes. And across countries, you can run the regression. And it would be very natural to think, and a lot of people for a long time thought, this stuff is all sort of BS. If you ask someone how good is your life on the ladder of life, they're just going to say, if they live in a really poor country and they're a rich person, they'll say that it's like really high. If they're in a rich country but they're poor, they'll say it's low. Turns out that's just really not true. So if you run the regressions within countries, they all have almost exactly the same slope, as you can see here. They're all about 0.35. And the regression across countries is the same as the regression within countries. So basically, no matter how you cut the data, and also this is true across time. So if a country is like increasing in wealth and other country is decreasing in wealth, that doesn't matter except to the extent that it raises the level of income. So basically, it all can be explained by this simple idea of your subjective well-being being 0.35 the log of your income. And so the log income specification seems to be a very robust way of thinking about how people at least perceive their subjective well-being from their material income. Okay, so a natural question is, if the wealthy value money less than the poor, why don't we just redistribute everything until we get perfect equality? Matt Green, could you, why in the theory of optimal taxation, if the wealthy don't value money as much as the poor, why don't we just redistribute until we get perfect equality?
Well, if you took a lot of money from the people at the top, they might not work as much. And if you're trying to maximize average utility, it might hurt them with the top more.
Yeah, that's right. So you don't want to, if you are taxing income, you discourage people from earning income. And that's a trade-off against the benefits of the people who value the money more getting it. And so beyond some point, it's actually counterproductive to tax more, right? Because I mean, if we just keep taxing, it could be that we discourage people from working so much that we actually earn less tax revenue to redistribute at that point. So a classic example of this was that actually the money that the federal government was making off of the tax on liquor was a big was a big problem standing in the way of the people who supported prohibition. Because actually, if you tried to tax it even more to the point where people didn't use it, all that revenue would go away. So taxing too low or too high always earns you almost no revenue. It's taxing in the middle that's going to do the best. And this leads to a fundamental trade-off that's often called the equity efficiency trade-off, which is that if you want to tax from the rich to the poor so that you can redistribute wealth, but the more you tax, the less that the rich will earn, and therefore the less money you'll have to redistribute. And so our goal is going to be to maximize average utility, given that we're only going to consider using some simple instruments, namely, yeah, Sean?
What's the difference between maximizing average utility and total utility?
Same thing. In this context, same thing. It gets subtle once we start thinking about new people coming into the world. But as long as the number of people is fixed, it doesn't matter. So we're going to only consider simple instruments. A linear tax, which will be applied on everyone in the population, and then a surcharge that will be applied on the rich. Right? And this is not because the real world tax system only has those two parts, but most of the intuition that you get out of thinking about like multi-part things, which get a bit complicated, you can get out of the simple two-part thing. And basically, the multi-part thing will just be a little extension of that. And we're going to assume that raising taxes can cause less work by the substitution effect, and that all revenue that we get is just given back uniformly to people in the population in a lump sum. That could be by offering education, that could be by just giving people back a check, that could be by offering public services. There's a variety of ways that redistribution could occur. But to keep things simple, we're going to ignore the income effects of the lump sum tax redistribution. In principle, if people are getting more income without having to work for it, that could just by an income effect cause them to work less. It's been found that that makes the formula messier, but it doesn't actually change the numbers very much, and so we're not going to worry about it today. But if you guys are interested, you can look at the Saez paper in the reading list, and that does the income effects as well. So the main inefficiency associated with taxation in this model is going to be that labor supply elasticity. That as you tax more, people are going to reduce the amount that they work, right? Because they can't earn as much more by working harder. So this is in particular, if someone's wage fell by 1%, then their people earning an income I are going to reduce their income on average by epsilon bar %. So if your wage falls by 1%, then everybody, there's lots of different people in the population, right? Different ones might reduce the amount that they earn by different amounts in response to an increase in taxes, but we can say that the average amount by which someone currently earning income I reduces their income is epsilon bar. Okay. And what is the income that people are going to receive? Well, they get, if they face a tax rate T, then they're going to get 1 minus T times the income they earn, right? And then they get back the average income in the population times the tax that's imposed on that, right? So their post-tax income is going to be 1 minus T average of the pre-tax income that they earn and the average pre-tax income in the population, right? So as the tax goes to 1, we get perfect equality. Everyone gets the average income. Okay. So the post-tax wage that people earn by working is their wage times 1 minus the tax, right? And Victor Liu, could you tell us or work out by if the tax rate rises by 1 percentage point, how much does that cause the post-tax wage facing this person to fall? By what percentage does it cause it to fall? Yeah.
So 1 over 1 minus T.
Yeah, why?
I don't remember why. Sorry.
Does anyone want to explain that? Or?
Well, when you take the derivative with respect to T,
Yeah.
it's going to be dw over dt and times 1 minus 1 over T.
Yeah, so it's just going to be W, right? dw dt is W, right? So d post-tax wage dt is just negative t, right? And then you want to say what percent, so you have to divide it by the current amount of the wage, post-tax wage, and that gives you negative w over w times 1 minus t, and that gives you that it falls by 1 over 1 minus t, right? Okay, so how much does average income in the population fall? Well, it falls by the average weighted by income, right, of the amount percentage by which people reduce their income, right? So the total amount of reduction in income is the average of the income in the population times the amount by which people reduce their income. By what amount do people reduce their, by what percentage do people reduce their income? Well, by the amount that by the percent that their wage falls times their elasticity, right? So that's up top. Down below, we just put the average income, so because we want to know the percent by which total income falls. And we get the average elasticity over 1 minus t. And here the average elasticity is not income specific, it's weighted across the population by the income, right? So this is a weighted average, just like when we did pass-through is a quantity weighted average. Here it's an income weighted average of the average elasticities. Okay. And this comes out of an assumption that there's a distribution of people earning different incomes, f of I. So again, we're going to ignore the income effects of the lump sum transfer. And now we can use this just to compute what would be the optimal tax rate. So what's the total welfare of people in the population? It's the logarithm of the average of the income that people, the average of the logarithm of the income that people earn, right? And why is this going to lead us to want to redistribute? Well, people who are earning less are going to have a larger derivative of the logarithm, and people who are earning more are going to have a smaller derivative of the logarithm, right? Because they're going to have a larger value of this term. So what happens when we take the derivative of this? So